Thomas.
My name is Richard.
It's very nice to meet you. And what we're looking at here, you're saying this is a spirulina algae column.
Yes, this is.
You have a biogas digester in that room.
In that room.
You're producing your biogas, which is about 60 to 70% methane and 30 to 40% carbon dioxide, a little bit of hydrogen sulfide.
Yes.
You're bubbling it down the bottom of this.
Bottom of this. Yeah.
As the bubbles go up, the spirulina is consuming the carbon dioxide, producing more spirulina.
Yes.
The methane that results at the top then is a pure quality methane, which you're then putting back into a storage vessel. Meanwhile, the spirulina you grow can be the feedstock or the food for the biogas bacteria.
That's true.
And you're using solar energy to produce that.
Yeah,
and that's why the window is here.
Yes.
An absolutely beautiful process. The question I have is, what happens, given that now you have oxygen also being produced, are you not sending back a dangerous mixture of oxygen and methane?
No, not. It's not that kind of. We're just experimenting it here because there is no other company or anybody that are using this both together. This is,
right, you're the first time using algae.
Yes,
plus
and biogas together to purify the biogas and to reach the more quality methane. Let me show you our digester. It is also a strange digester.
Yani bunu büyük, çok büyük tanklar halinde. Burada da minimum şey.
Yeah, naturally.
This is also a strange digester. We have got 5 parts here. We're feeding the digester from here, and stage by stage it goes, and we really have the best methane production from this stage.
Aha, as this baffles running all the way to the top and over still?
Yes.
Okay, so this goes up to here.
Yes, and these
chambers,
substrate never mixes together. It slowly goes from here to there, and it increases the
concentration,
productivity of the
productivity.
Digester.
So it's like a cow having 4 stomachs.
Yes.
Stomach 1, you probably have a lot of hydrolysis going on.
Yes.
So acid production in here.
Acid production here, purifying. I don't know what the stage is doing, and metal production is here and there.
And there. And so I don't see. So I see this baffle goes down to here. This one goes down to.
Oh, they are all in the same level.
They're all on the same level. I see. Okay. And so it goes like this.
Yes, that's true.
Okay.
And now we're trying to make it
insulation to make it warm. You have a heating panel.
There's a heat resistance in the this line. You know.
Yes. So that goes underneath here, underneath the insulation.
Yes.
Heats the tank from underneath.
Yes.
And then you have this mixer.
Mixer, and there's a heating resistance in the mixer also.
Oh, okay. Why the double heat?
Yeah, we're heating it inside.
Yeah.
And we're controlling it with this to make it stay on the, stable
stable temperature.
Yeah, temperature.
What about your pH?
Oh, we're controlling also from here. We have a software that we produced. We can control it from here, there are sensors in the
pH sensors in here? Or?
Yeah, it goes here.
Okay.
We control the pH.
pH from both from here and here? Two places?
2 places.
And you find it's much more acid here, a lower pH here, and a higher pH
also,
here.
Yes, that's true. Yeah, you really know this business.
Yeah.
That's true.
Yes, I do a lot of it.
This is a tank. It's working with the pressure of the water. Here is here is the Biogas Lab. Yeah, you see how it goes. And we take it there. When we open the water, it makes pressure and
pushes the gas out. Brilliant.
Yeah. And we took it now to demonstrate what we are doing here. I'm going to make a food, maybe eggs.
Yeah.
Later. If you do it, if you demonstrate it, I will take the video and I can send it to you.
That would be great.
Yeah, okay.
I would appreciate that. What is this chamber here?
It's another digester.
Okay.
We are trying to do some experiment to prove the productivity of this digester. We are digesting this also, and that also, and we are trying to prove that this digester is very productive than this.
More efficient.
Because
because of the stages.
Yeah.
Whereas this is a batch thing.
Yeah.
But do you do continuous feeding, or is it one-time batch, let it use up all the energy, then take it apart and put more, or are you feeding all the time?
It's a continuous system. Yeah, both are continuous systems.
And you're using food waste?
Yes.
Yeah.
Food waste. Sometimes,
cafeteria?
Sometimes, animal substrate.
Yeah.
Sometimes we use vegetables, probably.
Yeah.
Anything organic that we can use. And we have made, I guess, hundreds of experiments on other substrates.
Fantastic. What has been your experience with meat because of its nitrogen content? Do you find the pH is too alkaline?
Yes.
It is.
Yes.
And you have to buffer it with carbon.
Yes, that's true. We're buffering, yeah.
And why is the light continuously going on and off here?
It is there's a signal going to the engine here, and we are controlling that signal because we are still having some problems to control that engine there, and we are controlling the signal because it is really hard to work that engine in this slow speed. We also have to control the RPM here. And for slowing that engine is...
You're using the resistance of these tungsten filaments to keep the engine running at a slower speed.
Yes.
It's just a dump. It's a heat dump.
It's a heat dump, yeah.
Okay. Or electric dump.
Electric dump. We're just seeing how the signal, electric signal goes to the engine and watching it here.
Okay, so this is what's producing that electricity.
Yeah.
This motor is this is just being used to drive this shaft.
Yes, that's true.
But you're saying because you wanted it at constant speed, it would overdrive,
Yeah,
it would spin this too fast.
We are sending signals, and we are watching the signal from
sine wave.
Yeah, that's not.
It's just a dump.
part of the digester. Yeah.
Oh, it's because this would otherwise it would go too fast.
Yeah, it would go too fast.
Oh, that's interesting.
Because there's substrate in it, and it has to be powerful, also slow.
Powerful and slow.
Yeah. To make it slow, we have to use a card here. You see, in this one, these cards are produced.
Okay, so these are microcontrollers that are
they are produced.
running the circuit.
Yeah.
So this is all numerically controlled. Why is it that you? Why is it not just with gearing that you can get it to go slowly?
Because this is for our laboratories, and our engineers and some academic personnel are not like us. They always want to do it from here, by controlling from the LCD monitor, and then we are producing this for them. And also we are producing something that can really take your interest. We are making a 1 meter to 2 meter digester for
Small kitchens.
Small kitchens, and also for some small farmers. He's got 3 or 4 cows. We were always building some
10 cubic meters or 6 cubic meters. Right.
And we are also making business in Nigeria. And we also realized that we need some local and little digesters to make it work, because you can't just bring them together to make huge digesters. It's also expensive. And we decided to make some little versions of them. And next month we are going to build it in a village here. And then we are going to make it, how you say, mass production.
Mass production.
Yeah.
Fantastic. And you said that the water pressure is
Yeah.
doing things. Why are there 3 columns? Is that
Yeah.
is there a specific
I will
reason?
explain. There, because if I want to, I can close one of these, or one of these, or I can use 2 of them. It depends on
The gas production.
the gas production and the velocity of the digester.
The what? Velocity?
Yeah.
How the rate of production?
Yeah, and I wanted this to be to work with my other digesters also. When I use the digester, I only use one
Okay.
barrel feeder.
So they're separated.
Yeah, they're
Although
separated.
the water is the same.
Yeah, water is in the outside.
And yet I see a water
Yeah.
level here. So the water level is here now, but
Yeah.
inside the columns it's high.
It's high, and gas is, inside the column.
Do you find there's a rate, I'm seeing in my digesters a rate of every 5 seconds a burst of gas?
Oh yes, of course. It depends on the pressure of the
Sure.
water. Yeah, when the pressure of the gas eliminates the pressure of the water, it goes. And yes, that's true. It has a rate. When you look at your clock and watch it, you can count on it. Yeah.
So you go 1, 1,000, 2,
Yeah.
1,000, 3, 1,000, 4, 1,000.
We have just made a feeding to the digester, and it's really productive. 1 hour before, and there were no gas in it.
Really?
Yeah, it's a 1 hour production.
From there to there.
Yeah.
How many liters is that, do you think? It looks like 3 liters now?
I guess.
So maybe you're getting
3 or
3 or 5 liters an hour?
5 liters now. When it comes to here, we just export that. We can make some food here.
Yeah. My wife and I cook on biogas every day.
Yeah.
We have it in our house.
Yeah, that's very good.
Yeah.
When I see this kind of people using biogas, it's really good for world energy.
Yeah.
Yeah,
It's fantastic.
it's a
When you said now the gas from here is going out to the spirulina
yeah,
algae tank,
Yes.
and then it's coming back
Yeah.
here
yeah.
and going where?
Going to here,
Okay.
and to there.
Have you
No.
checked to see what the composition is of this?
No, not yet.
That's
Not
what I'm really
yet.
curious.
Yeah.
Because I keep thinking about the oxygen that's
You're
in
very
there.
lucky because it is so new.
Oh, it's so new.
Yeah,
I am lucky.
So new, yeah.
And then this is, what is this?
Oh, that's the oldest version of this.
Ah, okay.
It's the controller of this one because we bought it. There's a company. That company, Sartorius, and they're producing it, but we decided to produce our own
Neat.
controller units. Yeah.
And then this retort here, what was this being used for?
It's our production too. It's a normal digester. Yeah.
Just with a window to look
Just
inside.
a copy of this, but the bigger one.
Right.
Yeah.
Bigger retort.
It's also our production.
That's nice. Oh, I'm really privileged.
Yeah.
I hope you will come and join our Facebook group. We have a group called Solar
Yeah,
Cities
we-
Biogas.
We do too.
Ah,
I will add your page and
I would
offer
like
you
that.
ours.
please, thank
Okay,
you.
yeah.
And then I'll give you my card because we're 560 people from around the world doing this
Oh.
at the home level
Yes.
or the university level, and we like to share ideas and innovations.
Yes. This is a really good innovation because let me show you. We have more. Here we producing more.
Yeah.
You see the plants.
Yeah, very
culture
production.
here. Yeah. Because we have to hold this culture on us to produce more. When you make a pool,
Right.
then you use a little bit of this algae, and it goes and goes and goes.
Mm-hmm.
And if we really manage to bring biogas and algae together, that is fantastic because you make to go this one much more production, and you really purify your biogas from carbon dioxide.
In Italy, in the community called Damanhur near Torino, northern Italy, we started a biogas thing, and there now are bubbling CO2, but what they do that's different from what you're doing is they take the biogas from the ladder that they're holding it in, they pass it first through a sulfur filter, okay, some iron issue, then they put it in a biogas generator, generate electricity, and the carbon dioxide from the generator goes in the algae tank to grow the algae to feed back to the biodigester, but they're not purifying what you're doing.
We haven't just put a generator in this system, but we are thinking it.
Yeah, it's really, really easy.
Yeah, that's very easy.
There's a device I have that I showed today that you hook between the air filter and the carburetor.
Yes.
We get them from a company in West Virginia.
Yeah.
And that makes the regulation of air and gas, and so you can use any generator. You don't need to buy a special one.
We made some research about it, and we have found some really good generators to use them together.
Yeah.
Yeah, because when we think that to use this at little farms and for local villages, we really need that.
Yeah.
You lose some energy when producing electricity because heat transfers.
Yeah.
But it is really
it's the low Carnot efficiency.
Yeah. It is. I always say that it's better than sun and wind energy.
Yeah. People don't realize that. We've been saying in our work that biogas is the best form of solar energy.
Yes.
You're capturing photosynthetic solar energy that is stored in food waste, which is a better battery than a battery because it's waste.
That's true. You can really you're making an energy stock.
Yeah.
You can do it in sun. I made a research for it. You can maybe stock that energy in some ceramic things for 4 days, maybe. But here we can stock our energy all the time.
Yeah.
It is full of energy.
Yeah, I mean, methane can be stored for millions of years, so it's great.
We have just had our lunch to the digestion.
Right.
Yeah. And we are producing the cooking energy of our next lunch.
Yes, exactly.
Yeah.
Isn't it wonderful?
That's wonderful.
It's a bright new future.
You can think this system as free energy.
Yeah, it really is.
It's really free.
I'm really, really proud to meet you, excited to meet
Nice to meet you.
I look forward to continuing this
That's a
dialogue.
good card.
I'm looking for it. I can't find it.